victog.com.
Today we are going to study about the molecular basis of inheritance. The topic deals with the genetic material of an organism. What is genetic material? Genetic material actually it comprises the all things in an organism. That is genetic material determines the all activity or anything regarded to an organism, that is genetic material. And here genetic material determines the composition of an organism. And genetic material, mainly the genetic material are of two types, that is RNA or DNA. These are the two types of genetic materials we have. DNA is the deoxyribonucleic acid and RNA is the ribonucleic acids. In most of the organism, DNA is the genetic material, but in some organisms, selected viruses, etc., RNA is the main genetic material. In coming to DNA, that is deoxyribonucleic acid, it is the genetic material found in most of the organism. And DNA, actually DNA or RNA, it is nucleic acid. Chemically, it is nucleic acids, and it is also known as nucleotides. So, in DNA or RNA, numerous nucleotides are present, or it is the polymer of nucleotides. So, we can see it as a polynucleotides. It is known as nucleic acids and also known as polynucleotides. In DNA is double-stranded, but RNA is single-stranded. Then, the length of a DNA is determined as the number of nucleotides present. When we coming to the structure of a DNA or DNA or RNA, that is genetic material, we can see that there are three parts. It is nitrogenous base, pentose sugar, and a phosphate group. These three combined to form a genetic material. Chemically, it is formed of nitrogenous base, pentose sugar, and phosphate group. And nitrogenous bases are actually there are two types of nitrogenous bases, that are purines and pyrimidines. Purines is adenine and guanine. These two are nitrogenous bases are considered as the adenine, and pyrimidine is three types of nitrogen bases are present in pyrimidines, that is cytosine, uracil, and thymine. And here, cytosine present in both DNA and RNA, but uracil is found only in RNA and thymine is found only in DNA. These are about the nitrogenous bases. Actually, we can see that the structure of a polynucleotide or DNA is mainly composed of three structures, three parts, that is nitrogenous base, pentose sugar, and a phosphate group. And nitrogenous bases are of two types, purines and pyrimidines. Purines is composed of adenine and guanine, and pyrimidine is composed of cytosine, thymine, and uracil. Pentose sugar is also a part, and phosphate group is the another part. These three combine to form a polynucleotides. Here we can see that the nitrogenous bases are combined with this pentose sugar in a N-glycosidic linkage or N-glycosidic bond and forms a nucleoside. Actually, DNA or RNA is nucleotides, polynucleotides. The first step is a nitrogenous base. A nitrogenous base combined with a pentose sugar through a N-glycosidic bond and forms the nucleoside. Nucleoside only forms the nucleoside. After that, these nucleosides combines with a phosphate group through phosphoester bond. Through a phosphoester bond, the phosphate group is combined with the nucleoside. Then this forms to a this forms a nucleotide. Actually, the nitrogenous base are linked to the pentose sugar through N-glycosidic linkage. N-glycosidic linkage and forms a nucleoside. Then this nucleoside combine with a phosphate group to form a nucleotide. And then we know that the polynucleotides are group of nucleotides. One nucleotide combines with another. There is a numerous nucleotides are present in the polynucleotides. Then the two nucleotides then combines with the 3'5' phosphodiester bond, forming a dinucleotides. Dinucleotides are nucleotides, a group of two nucleotides which are connected with the 3'5' phosphodiester bond. Then here is a general structure, general components found in a DNA genetic material. Here we can see that phosphate group, triphosphate group, and a nitrogenous base and sugar. These three, and the nitrogenous base are purine and pyrimidine. Their structure is also here. In the case of a nucleotide, there is a 2 ends, that is 5' end and 3' end, and 5' end is composed of a phosphate group, and 3' end forms the OH group found in the sugar molecule. Here it is the only case of DNA, but when coming to the RNA, here there is an additional OH group present in the 2' end of the RNA. So due to the presence of this additional OH group, the RNA is more reactive than the DNA. So RNA becomes more unstable than the DNA. Here it is the structure of a DNA. We can see that it is in the picture we can see there is a nitrogenous bases and the structure of a DNA. Actually DNA is the double helical in structure. 2 strands are twisted, coiled to each other, and actually the sugar and the phosphate group forms the backbone of these double helix, and actually the nitrogenous bases are facing inside towards these coils. For knowing more about the structure of the DNA, we want to study another theory, rule. It is known as Erwin chargaff's rule. According to Erwin chargaff, for a double-stranded DNA, the ratio between the adenine and thymine and the guanine and cytosine are constant and equals to 1. According to Erwin and chargaff, he says that in the case of the DNA, the ratio between adenine and thymine and guanine and cytosine is always a constant and it is equal to 1. Both DNA and RNA are regarded as the genetic material of an organism, but in all these cases, DNA is more favorable as a genetic material than the RNA. Why DNA is better than the RNA? There are some reasons for it. DNA, actually, due to double helical structure also, the DNA is chemically and structurally more stable than the RNA, and the presence DNA has a pyrimidine present in the DNA is thymine, which is not found in the RNA, and due to the presence of the thymine, it gives additional support to the DNA. DNA is chemically or structurally more stable than RNA, and the presence of the thymine actually it confers more and additional support to the additional strength to the DNA, and the thymine is also have some additional property, that is thymine is used for DNA repair. For DNA repair, thymine is used, and another reason is RNA has an additional OH group present in the 2' end of the 2' end. This is where this group is reactive and more reactive, and it is degradable, and it gives the property of RNA as an unstable compound. RNA also has the property of catalytic activity, and then RNA can undergo mutation more easily than the DNA. Then these cases, that is DNA structurally or chemically more stable than RNA, and due to the presence of the thymine also, and in the 2' end there is an additional OH group is present for RNA. This gives then more reactivity, and it is more degradable. Then RNA has a catalytic activity. In another case, RNA can undergo mutation in faster rate than the DNA. So DNA is more stable compound as a genetic material than the RNA. Here is the picture of DNA and RNA. DNA is deoxyribonucleic acid and RNA is ribonucleic acid, and nitrogenous bases are found in the DNA, and RNA is also shown. DNA is double helical structure, but RNA has single stranded.
We are getting.
Next monsoon season is East Asian monsoon season.
It actually contributes to the well-being of the society.
What do you mean by the word physiography? Physiography means
What is the definition of classification? See, classification is simply
DNA means deoxyribonucleic acid and RNA is ribonucleic acid.
after evaporation, the parcel of moisture that becomes
വർത്തമാനകാല ക്രിയ എടുക്കാൻ വേണ്ടി ആ ലകാരത്തിലുള്ള